Hello everybody. We're gonna have another wonderful day of doing some quasi-extreme programming together. I've just set up a script that records and automatically uploads to YouTube using the Google CL framework. I don't know if it works, so these videos might not even get posted, but it's worth a shot. So where we left off, let me pull up the application really quick. I'm not going to debug it. Oh. Sorry. I forgot that. I forgot that because of the way it's set up right now, I have to use headphones. So we'll plug in some headphones. Put the headphones near the mic so you can probably hear it. I realize that this sounds like really crazy thunder when you touch the mic, but just bear with me. So let me start the program up. So it's at the point when sound is made, then it creates these bouncy balls. There seems to be some cases where it creates too many, so I want to deal with that first. Let's make a list, actually. Yeah. So I'll use this window here because it's not being used for much. To do today. First, we want to fix the case where too many notes are spawned. The next item is right now the program does crash when you get too many of these guys floating around, and I like to figure out why. But yeah, that's like a low priority, but I would like to get around to that today. Because the program shouldn't really be crashing. Look into program crash. Then we get to play with the lovely new debugger, which I'm really afraid of in Xcode 4. Oh yeah, coffee. Okay, so what was I going to do besides all that? Okay, so right now we've got this many entities going on, and very soon it's going to crash. So I just keep talking into the mic. Looks like around 100 or so is when it starts to crap out. I mean, animation works fine. It's still rendering at, well, at least a reasonable number of frames per second. Now it's really starting to fill up. Note that, yeah, and it looks like the collision detection is starting to crap out. I notice when the object hits the top of the screen, sometimes they exit. Did you see that? So that's another thing to look into. But I'm going to convert this app into less a collision detection app into a voice conversion app. So that's not high priority. It's interesting that the problem only happens at the top of the screen, though. I'm not really sure why. Okay, anyway, it's not crashing this time, but okay, the other thing I'd like to do is an aesthetic thing, well, functional thing, and that's the fun part when you start changing the functionality. I would like change the sign objects, and by sign I mean the mathematical sine tone that we're outputting to use to new recorded buffer objects. So I would like when those squares start getting formed by the voice to actually when they collide, instead of outputting a sine tone, they will output their sound. I'm not sure how that's going to work, but that's going to be useful because we will need an object to track the actual buffers and keep track of the references. And on top of that, right now you notice if I keep talking into the mic, there will be an initial square that pops out and nothing after that, as long as the sound is continuous until it decays, until we release the sound. So there's no correlation between size and length of the sound. I would like to be able to represent that visually, so that's another change I want to do. Make the size of the object, the note onset object, proportional to the, what do you call that, length of the sound. Okay, so here's 4 little items that we could do today, but let's prioritize things. This is the first thing I want to get to because it's pretty fundamental, and these next two depend on that. So how about that? I like that better. And the crashes, we're not really gonna have to deal with that. That might just be a memory issue because I'm not sure. I just remembered something though while I'm at it. I use malloc to allocate these guys, and I had a dream about this last night. I'm deleting these guys. That's no good. Really, I should be freeing them. And not only that, but here's the important part. We are memory leaking right now because if you look in our callback, so we're allocating n input buffers, which are our own structure. But allow me to go to the callback. Did I pass it? Is it here? No. It is something audioio.mm or something. Yeah. Never mind. Okay, so here's a buffer, right? And here we render to it. Right. So in request unused buffer, see we malloc one of these buffers, and that's not. There's 2 mallocs that happen in Input Manager. One's here, the other's here for input buffer. But we also do the internal buffer, the void star buffer, which happens to be the actual audio buffer, in a different malloc. So that means when we free things, we have to do both. And you do that by also freeing the internal buffer before you delete the outside containing structure. I think that's why it was crashing. We could test that, but this is a fairly safe change to make and correct change to make. So let me, maybe that's dealt with. Alright, so fix the case where too many notes are spawned. How does that happen? Why is it that so many notes get spawned? Well, let me tell you why. We are constantly... Do I still have that lovely picture? Yeah, this is totally incomprehensible. So I'm gonna draw another one. How about I make a new one and discard that? Yeah. So again, power, time. Oh, you know what? I have all this space. Power and time. Yeah. T. P. Okay. So there's generally an idle state which we'll call the noise floor. Basically what happens when no one's talking into the mic. Then when somebody says something or something happens, it spikes up. With voice, it's not exactly percussive. You can start slow and slowly get louder. Because it uses an excitation resonance kind of mechanic. But say it looks something like this. So this is not the best example, but say this is our onset. Yeah, and say it does something like that actually. We have eraser. Yeah. Okay. This is our onset, and this is our offset. Looks like I have to do some more work. Okay, this is the offset. It's not good. Okay, say it does something like this. This is kind of a common case. And we have to handle all the cases. So they say something. This is the actual event we want to capture. One event. Yeah. And with our onset being here and our offset being here, this is pretty good. I mean, there's always going to be a point where it goes up and down close together. And actually this case is handled by our model. Alright. One more. So this case is completely okay. This is not an issue. But this one is. So when I say a sentence, it may be a word. Sometimes there's a quick pause in the word, in between words. For example, when there's a plosive, like example in between the M and the P, you're going to get a little quiet for a little while you close your mouth. Example. And the sound's going to look something like this. It would be example. And these sounds are pretty close together. These happen in like maybe a quarter of a second or so. And this gap could be really, really small. And what we could do is just disallow really tiny gaps and say there's a minimum period. And also, this is a really, really anal area of the design, so I'm gonna just skip it for now until I find some concrete examples where things are happening. But the one that I think will be good to have is right after a sound finishes, wait a little while